Welcome back, everyone. In this video, we'll explore non-parametric statistics and how they are used in educational research, particularly when our data don't meet the assumptions required for more traditional methods like t-tests or ANOVAs. So what exactly are non-parametric tests? These are statistical tests that don't assume your data follow a specific distribution like the normal curve. They're particularly useful when your sample size is small, when the data are ordinal rather than continuous, or when the assumptions of other tests, such as equal variances or normality, are violated. Non-parametric statistics are especially valuable in educational settings because we often work with small groups. Think of a preschool classroom with 12 students or a pull-out intervention group with 6 middle schoolers. In these cases, the sample size may be too small to meet the assumptions of parametric tests, but we still want to analyze the data rigorously. Non-parametric methods give us a way to do that. Let's consider an example from early childhood education. Suppose a preschool teacher is implementing 2 different picture book read-aloud strategies and wants to see if one approach is preferred over the other. The teacher might ask each student to rank the sessions. Because the data are ordinal and the group is small, the Wilcoxon-signed rank test would be a good fit. It allows the teacher to compare paired responses without assuming a normal distribution.
Another commonly used non-parametric test is the chi-square test. This is particularly helpful when we are working with categorical data. Let's say you're investigating whether there is a difference in high school students' preferred learning styles, visual, auditory, or kinesthetic, based on gender. You would use a chi-square test for independence to determine whether the distribution of preferences differs significantly between male and female students. Now imagine you're an early childhood researcher looking at whether the days of the week affect birth rates at a local hospital. You count the number of births on each day of the week and want to know if those differences are statistically significant. Because this is count data across categories, the chi-square goodness of fit test is the right choice. It helps us determine whether the observed distribution across categories differs from what we would expect by chance. Here's another real-world example. A district administrator wants to know whether boys and girls are equally represented on elementary school robotics teams. If the school has 200 boys and 180 girls, and only 10% of participants in robotics are girls, a chi-square test would help evaluate whether this imbalance is statistically significant.
Non-parametric statistics can also be used in high school settings. Suppose a teacher wants to compare student satisfaction levels across 3 different instructional formats: in-person, hybrid, and fully online. If students rate their satisfaction on a scale from 1 to 5, those ratings are ordinal. The Kruskal-Wallis test, another non-parametric method, would be an appropriate tool for comparing medians across the 3 groups. Let me emphasize this again. One of the greatest advantages of non-parametric tests is their suitability for small sample sizes. In educational research, we are often not dealing with hundreds of participants. We may be analyzing data from a single classroom, a pilot group, or a specialized program. In these cases, non-parametric tests allow us to make valid inferences without overstepping the boundaries of what our data can support. The beauty of non-parametric tests lies in their flexibility. They are less powerful than parametric tests when all assumptions are met, but they are far more robust in situations where data are skewed, categorical, ordinal, or limited in size. Remember, in educational contexts, we often deal with messy, real-world data that don't always fit the clean assumptions of normal distribution. Non-parametric statistics allow us to still analyze these data rigorously and meaningfully. Thanks for tuning into this session.